It's a story what hydrogen trucks can do for the country, how we see that hydrogen trucks really can make a difference over here. So, as you can see on that first picture, a few months ago, your good president even listened for about 40 minutes to our story. I'm happy to share also a bit of that story again to you today. So first of all, presentation topics, but I skipped this one to save 1 minute in my presentation. So first of all, I'm part of the CMB group, and I would like to give you some framework why we are doing this. Because as you can see, the ship on the picture, we are in fact a Belgian shipping company. We operate and we own about 150 ships. 100 of them are ocean going. As you can see on the picture, these are ships which are carrying about 200,000 tons of iron ore or still coal. And as you can understand, we are consuming a lot of energy. It's about, if you look towards our diesel consumption, it's more than double what Namibia uses as a country that we use to power our ships through the water. And also, we believe that the energy transition will really shake up our shipping industry. And we also believe that shipping will play a role in that energy transition. If you look towards our fleet, we have container ships, dry bulk carriers, chemical tankers. But all in all, as you can see, there's a picture with people. We are a family-owned company. We're 120 years old, and we believe in the power of people. And that's why we have decided 7 years ago that we should start investing into hydrogen technology. So the two pictures, you see our crew transfer vessel. It's already in commercial operation. It's hired by Vestas to bring people to the offshore windmills. It's powered by more than 2,000 horsepower of hydrogen. Next to it, you can see a picture of a refueling station, and there you can see we are building our maritime campus program. So we see that investing into the youth, investing into people is an important aspect to make a change. Talking about the clean tech division, because that's something new that we introduced 7 years ago, is that, of course, we build ships, and for that, we need very good, smart, and bright people to come up with the good ideas, because we need to win from competition. Competition is in the Far East. They are cheaper, they build them cheaper, operate them cheaper, but we think we should build them smarter, more efficient. That's where our competition can be left aside. And then we noticed that solutions we develop can be used in other industries. And maybe these other industries can help to accelerate our own business. Right? Therefore, we have a strong belief in ports, and also on the picture of the truck. I'll explain in the next slides why we see the truck as part of our story. And then, of course, if you come up with new fuels, you have to think about how do you produce the fuels, how do you get them. And so we are running a project over here. So all in all, we're working on hydrogen for, let's say, about 15 years. In 2008, we had our first, let's say, on-road application on hydrogen, and in 2012, our first dual fuel, because we can understand that, yeah, the chicken and egg story needs to be solved, and we have some solutions for that. Why Namibia? We are a world operator, and we believe in the strength of Namibia. It's not only because there's a nice, let's say, sun image on the flag of Namibia. They said, we have to be in this country. I can tell you, we looked in the full of Africa. We did at all major ports. And what we have seen over here, how we have been welcomed, how we have been supported and making our roadmap, let's say, be realized. We are very, let's say, charmed. And also, we have come to meet with the ONL group, which are now, let's say, our partners in crime. And we are married to make this happen over here. And yesterday, we were very, let's say, happy with the news that we also, our project of Clean Energy, received support to realize in Walvis Bay area the first green hydrogen production plant with also offtake towards the end users. But this is a story not started the past months. It's a story we're working on for about 3 years for now. So this is one of the pictures. I believe it was shown yesterday. But in fact, it's a solar park directly connected to an electrolyzer to produce hydrogen, compress it, store it, and then start to distribute it. We can do, but we can also bring it towards bigger users with tube trailers, or we can dispense it at the refueling station. And at the end, we think the big consumers are, I'd say, locomotives, genset, trucks, whatever. I think big users who use a lot of energy, who consume a lot of fuel, these are the best ones to let them run on hydrogen, to save on cost. And by incident, by running on hydrogen, we also save on emissions. And by coincidence, all these applications, they are built around the combustion engine, typically the diesel combustion engine. And that's why we have had some focus on. If you look towards the location, we have decided for Walvis Bay because we believe that you need to have some kind of ecosystem, a hotspot, where everything comes together. For your first project, we believe you should be near, for example, the access from the sea. You should have the road access. I think on a daily basis, 2,000 trucks are driving around at that June 7 highway, but also locomotives who are passing by. I think looking at what the potential is of that project, and honestly, with our support, we are, let's say, aiming at opening end of next year. We can be one of the first real green hubs in the world where, for example, a ship can enter, bring, for example, the cargo to the shore, powered by hydrogen, transport it to the end customer, everything powered by hydrogen, and we can learn the people, and we can be a fully scalable project, knowing that in a few years it will be the cheapest fuel there is available. And we can also look in the neighboring countries to bring on a very low cost, very clean, very energy efficient. We can bring these goods towards our port to export, and thereby avoiding the expensive import of diesel fuel. Anyhow, technology, I'm happy to answer questions afterwards, but feel free also, if you are in Europe, Belgium, you can visit one of our plants. But this is already an upscaling, and we can even upscale this by 6 times without doing, let's say, very big new investments on the installation. Hydrogen trucks.
2 minutes, please.
2 minutes, please. Okay, I'll run a bit quicker. It's not a fight between fuel cells or batteries. I think you should use batteries where you need to use batteries. But as soon as the cargo or the power increases, you see that you make a certain shift from battery powered to fuel cell powered to combustion powered. And I can tell you, every truck manufacturer is working on hydrogen solutions. There are fuel cells, there are combustion engines. I think on the right top one, there's even the dual fuel combustion engine that we are working on. But people are working mostly on compressed hydrogen, some of them also looking into liquid hydrogen. I think that market will, let's say, converge over the next years, but I believe that it has to start somewhere. And the difficulty with fuel cells is, of course, the autonomy. You can refuel your 6 tanks on your truck. It's around 30 kilograms in about 10 to 14 minutes. And I use the picture of our Prime Minister, because he did the first refueling of our truck in Belgium. So you don't need to be educated with respect for our Prime Minister to refuel a truck. Without training, he was able, the only thing he asked, what's your PIN code to pay at the terminal? So I think it's a good point that we can scale up. But what is the main problem with fuel cells? You're talking about a fuel cell which produces electricity, it's direct current, but then you only have your subsystems, which are now easily on the drive belt of your engine, but then you need to have an air compressor, that's AC, you need to have for your wipers, that's a different one. So it's a lot of complexities, a lot of expensive equipment, which the people here, also in Europe, we don't have the technicians yet to do that. There's a lot of, let's say, learning curves to be made in that kind of equipment. How will they operate at high altitude? These heavy loads, because often 60 tons is being carried over here instead of the 40 tons what we have in Europe. There's a lot of complexity involved with that. So therefore, we believe into a dual fuel technology. What is that? It's just mixing hydrogen into the combustion engine. So we aspirate hydrogen in the engine, we compress it, we use diesel for kickstarting the ignition, but this has the advantage if you don't have diesel, if you don't have hydrogen, the engine can still running on diesel. And we believe that is the right thing to do if you are solving the chicken and egg story. Going forward, this is how it works. You see standard engine, we just install the injector ring, we have some software to make certain that it is safe, we install the hydrogen tanks, and that's something we are importing as well for our demonstration hub. 5 trucks will be on dual fuel operating by the end of next year. This is how it looks. Depending on the mixture ratio, we can drive up to 1,000 kilometers on that system, and even if the hydrogen tanks are empty. So we believe that is a way how to kickstart. As soon as there are more refueling stations, more hydrogen available, we can shift towards, let's say, higher savings percentage. And if hydrogen is available everywhere, we can go towards monofuel. That is the cheapest solution available today, and we can easily train the local people how to do the maintenance, because the maintenance on a hydrogen tank, that's not that difficult. Even on a valve, it's not that difficult. There's a simplicity, there's the means to use a cheap fuel. That's where we see the main role. But of course, there are other applications, and I think for locomotives it's the same. Just install tanks on a carriage, trying to mix it into the engine. But again, mining trucks, these are also part of the heavy users of the diesel oil, with all needs to be imported, which comes at a very high cost for the country. But I believe, well, next to the mining side, you can create your own solar plant, you can reduce your fuel, and you can, with that mobile refuel, you can refuel them into the field. And it's the same for ships. You see that container ship, one of ours comes to the port of Walvis Bay, and then the tugboat pushes the ship to berthing place, and even that tugboat can be run on hydrogen. By the end of the year, we're going to have a hydrogen tugboat in Belgium, and we would like to do the same over here. But it's the same for the port equipment handling, the straddle carrier, RTG, forklift, reach tank. All this equipment are equipped and expensive, also not expensive with the diesel engine. And I'm going towards the last slide, some takeaways. I think transport logistics is important for the country, and most of these equipment can run on hydrogen, so that's a very important one. I believe the heavy-duty long haul, which is quite relevant for Namibia, I believe the dual fuel approach is the right one. And if you look at just into numbers, if you look at Namcor's import facility of diesel oil, I think every month about 50 million liters imported. If you convert that of energy equivalent, it's about 147 tons of hydrogen a day. With pure sun and a 1 gigawatt electrolyzer, we can already produce this. So it's not these far numbers of gigawatts that we need in order to do that. If you look towards the cost of that diesel, that's $320 million that can need to be imported, that we can produce locally, and then also saving emissions. So I believe that hydrogen will play a key role in making the logistics cleaner and cheaper, and it will create unique opportunities compared to any other competitor worldwide due to its abundant capacity of the country. So this leaves us for the Q&A, but I'll take a seat because I see it in your eyes, the fire is coming out. And I hope you appreciate the extra time that I received, and thank you all for your attention so far, and I look forward to the panel discussion afterwards. Thank you.